right, well, the music turned off, and that guy told me that I'm supposed to come up on stage now, so let's have a talk about security. Yay! Congratulations, everyone. You made it. It's the last day of the conference. When I think about the kind of topics I want to hear about when it's the last day of a conference, I'm tired, I've been having a good time, I just had lunch, I'm warm, full belly. Security in the cloud is not exactly the most exciting thing in the world to everyone, so I want to thank you all. I'll do my best not to put you to sleep. We're going to have some fun today. We're going to look at a couple of demos, talk about some problems, and hopefully make some bad decisions along the way, because that's where we actually learn our lessons. Before we get all into that, my name is Justin Beckwith. I'm an engineering manager at Google. A lot of the demos that we're going to look at today, you're going to be able to find on GitHub. If you want to reach out to me or get into contact with any of the teams that make the cool products that I'm going to talk about today, then all my contact information is there. Feel free to reach out. For those of us in the information security field, this has been kind of a rough year. It's been a hard year to watch. We've seen multiple high-profile breaches. I'm going to not do those companies the disservice of putting their logos here or any of the news clippings, but we've seen several incidents where companies were careless with their customers' data. This is a real problem. And the worst part is, it's something that we tend to think as engineers or as IT admins or sysadmins, we tend to think that it's a problem that we can just solve with technology. There's a specific product that can help us lock it down this way. There's a specific thing that we can use here. While in some cases that's true, the truth is this is really a consumer trust problem. Because the moment that we take on a customer's data and they've made the relationship with us, they've trusted us with that data, and then we lose it, we have a breach, that relationship oftentimes is impossible to repair. It's not something that we as business owners can ever get back. The impact globally, according to a recent report, of an average data breach is about $4 million. Now, this is average, going anywhere from a small security breach, which no one likes to think any of them are a small deal, all the way up to something like what happened with Equifax, where the effects are going to ripple for quite some time. And that's not anything that any of us want on our watch. It's not something anybody wants to expose their customers to. The truth is, security, information security in the cloud with user data, this is a business problem. Once that trust is lost, it's not coming back, not easily. We need 10 positive interactions to make up for one negative interaction. And if you lose someone's customer data and they lose their social security number and have identity fraud, then, well, it's going to take maybe more than 10 good interactions. But good news, there are no magic bullets. There's not one thing that's going to fix this for us. And if anyone's trying to sell you one thing that's going to fix security in the cloud, you probably shouldn't buy from them. Nothing is going to make you 100% secure. But what we can do is we can identify the most common risk factors, the highest risk factors, and we can reduce that risk. We can mitigate the highest risk factors. And that's largely what we're going to talk about today. We're going to be taking a look at preventing and mitigating known vulnerabilities in our software stack through containers, through virtual machines, through the software that we're actually running inside of our applications, and find what are some of the most common ways that they can be compromised, and how can we mitigate that? How can we reduce the surface area for a potential attack? When I talk about vulnerability protection, I like to think about this in 3 different buckets. The first place, where not a lot of people really think about, is at code time. Increasingly, the software that we're building or that our software teams are building are comprised of third-party components. It's not like it used to be where you would have one giant standard library, you would build your application, you write 100% of the code, and you know exactly what's in there. How many of us here are using something like NPM, Maven, pip, Go-Git, any Go-Git packages, Composer? There's one of these. Every language ecosystem has a third-party ecosystem that increasingly has become critical to the success of our software. So for all those people that raised hands, how many of you read over every line of code that you're importing into your application? That's amazing. I want to know how to scale that. We need tools. We need better tools to tell us, yes, we want to enable our developers to be successful and to go build great things and use what's out there in the community. At the same time, we need to make sure that there are no known vulnerabilities, and that, honestly, in a lot of cases, that we have the appropriate licenses in place, because it becomes not just a security issue, but a compliance issue as well. The next phase of vulnerability prevention comes at build time. And this is where, if you're a containerized organization, there are a lot of great options for you out there, because we've started to take what used to be purely at the deployment time and in the infrastructure stage, and we can now pull that all the way back into our build time processes. I want to know what operating system are we using, which distribution, which version, what packages are installed. Can I compare those packages against a list of known vulnerabilities? And then lastly, once I have all that information about the build, can I give it, in my CI system, the good old thumbs up or the thumbs down? And that brings me to the last part of vulnerability prevention, deployment time. So you've built your container, you've built your application binary, you're ready to send it into production. What are we doing at prod time to make sure that it's done all that other checks and all those other things we said it would do? How do I know that there are no third-party packages with vulnerabilities? How do I know that we did a scan? How do I know that my build system is the one that produced that build? How do I know this isn't just an arbitrary binary that one of my developers made on their local machine who possibly is disgruntled or they had an attack on their desktop? These are all questions we need to think about at each phase through our software development lifecycle process to be able to reduce that surface area of attacks. Today, we're largely going to be talking about build time and deployment time as it relates to containers and Kubernetes. So lastly, security, it's easy to say, oh, this company had a huge breach, they were negligent, individuals were negligent. It tends not to be a people problem. It's not that any one person wasn't doing their job. It tends to be a process problem. We need to ask the questions, how do we know our software is secure? How do we know it's verified in the build? And then how do we know if there are any new ones once it's already in production? It's not enough just to stop vulnerabilities from getting into production. We have to react after they're there. And for each of these phases, we need to have a well-defined process and a set of tools that helps us commit to that process. And that's what we're going to talk about today. It's a process problem. And I'm going the wrong direction. Let's go this way. All right. So now we've done a lot of talking. I want to show how some potentially benign-looking applications can actually expose pretty significant holes that allow you to take down an app. So we're going to talk about my terrible, horrible, no good, very bad day. This is a fictitious story. This did not actually happen. Any similarity to any production service, living or dead, is merely coincidental. All right, so a fairly typical application architecture that you might find in Google Cloud is going to be run on top of Kubernetes engine in my case. I have a front-end service that's individually scalable. I have a back-end service that's scalable. The two are connected via gRPC. We have the Cloud Vision API. I have cloud storage for files. I have some other random API here off in the distance that I'm calling. But in terms of a typical business application that's being built in a containerized workflow, this is it. And this is the type of app that we're going to look at and how I actually personally made some pretty bad mistakes when I built the app that we're going to see. And of course, my boss is over there saying he totally trusts me. He's positive I'm going to build this mission-critical app and it completely won't have 100 vulnerabilities that'll tank the business. I appreciate his confidence in me. I don't know if he's out there or not. And so our totally mission-critical business application is going to be about cats. This is actually my cat. That's Boo Boo Bad Kitty. And can we move over to the demo? It's going to look, I actually don't know if it's the demo because it looks exactly the same as the slide. That's interesting. But I can see my mouse moving around, so I feel pretty good. So what this mission-critical business application does is it's actually going out to Reddit. It's downloading images from r/aw, which is cute animal pictures if you've never seen it. And then it's categorizing them into two buckets. On the left, we have cats, and on the right, we have dogs. And it's using the Cloud Vision API to figure that out and sort it all together. So it looks like the dogs are out to a bit of an early lead. We have the cute dog with the watermelon. There are puppies. Cats are following a literal box of cats. That's just going to count as one. Like I said here, this is very important to the business because we're trying to make people productive. I need cute pictures of animals to stay happy. If I'm not happy, I'm not productive. Therefore, business critical. We have the Leia cat. And look at that. Dogs win. That was half-hearted. Come on, let's hear it for dogs. Fun fact, I wrote this app 3 years ago. Dogs always win. It's the weirdest thing. And I actually have years of data in BigQuery to prove it if anybody's interested. All right, let's go back to the slides. Actually, so this is a pretty simple application. All this is really doing for the front end container, it's using an out-of-the-box Node.js container that I found on Docker Hub. I went on Docker Hub, I searched for one, it looked fine, I used it. Yeah, exactly. This was 3 years ago. Give me a break. I exposed a port on it, and I run the final command. So knowing what I know now that I've been at Google for a while and kind of going back and trying to fix that, it just so happens that the container I had used had a couple of minor vulnerabilities in the distribution of Debian it was using. It's using a version of Node.js that is completely out of support, not receiving any security updates. None of the third-party components, the NPM modules I was using, are getting patched, and it's just been kind of hanging around. So let's go over to a demo and see what we can do. This is always fun. Can we go to the demo? Yay! There we go. All right, so this is the source, and this particular version of Debian unpatched was susceptible to a neat little drip attack. So I can run attack.sh. We're going to wait. Hopefully this is not a problem for the Wi-Fi. We're going to open a bunch of HTTP connections, but we're not going to send data. We're just going to slowly drip, drip, drip bits of data with a bunch of open connections. Let it warm up. All right, so we did it. So I'm going to open a new tab, and let's see. If I go to cats.jbeckwith.com, I've never given a demo where the point was for the demo not to work. This is new for me. We did it. I was able, with a simple bash script, to take down my own site. Thank you. Oh, yes, I mean, this conference Wi-Fi is terrible. It's always causing problems. So let's cancel that out. We're going to give it a minute. Let my service breathe. It's on Kubernetes, so the good news is that after everything falls down, the pods will probably restart. And if the attack has stopped, and I'm back. All right, so can we go back to the deck? So that's not good. That is very bad. This is not what we want to have happening for any of the applications that we are responsible for running. So how could this have been avoided? To help avoid issues like this, that's why Google is working on the Container Registry Vulnerability Scanner. Say that 3 times fast. Container Registry Vulnerability Scanner. I'm not going to try. Now, the vulnerability scanner, it will detect vulnerabilities before deploying to production. Today, the types of vulnerabilities we're detecting are in operating systems, operating system packages. We have an eye towards the code and third-party ecosystem that we discussed. We give you notifications when we find those in a variety of ways that we're going to look through demos of today. It supports Debian, Ubuntu, and Alpine with Red Hat Linux and CentOS on the way. Integrates with existing tools and workflows, and we're going to see a couple examples of Glue of how we can do that. And it's currently available in alpha. And there's actually going to be a link at the end of the deck of how y'all can go sign up and try it out if you'd like to. So enough jibber jabber. Let's go take a look at the demo machine again. All right. So we talked about the image I deployed with a whole bunch of vulnerabilities. I'm going to go over to the Google Cloud Developer Console. This is my CloudCats project. And what we're going to see is a little bit of interesting new UI that pops up in the Container Registry UI. So for those of you who aren't aware, Container Registry is Google's high-performance, secure place to store all of your Docker container images. And that's what I'm using for this app. I'm under the CC web directory, and you can see all of the images all of the tags that I've pushed, all the SHAs I've pushed for this particular container. And you can see here, 623 discovered vulnerabilities. That's a big number, but what does it actually mean? And so I'm going to dive in one level deeper, and we're going to take a look. Within that, 10 critical, as rated by the CVSS score, 100 high, 417 medium, and you can read the numbers on and on. So we're going to give you a detail for each of the vulnerabilities that we were able to discover inside of the container, how critical it is, if there's a fix available, the package, and then lastly, most importantly, a link out to the CVE document so that you can read what happened, how to patch it, what is the actual risk. So let's take a look at one of these. I'm going to click on good old 4448, one of my favorites. And we can see this is a bug inside of libxml2. It looks like it was vulnerable in Debian Jessie, which for those of you who follow along with Debian, there's a Jessie, Stretch, and then the latest is Buster, but I don't think it's LTS yet. Stretch, I'm pretty sure, is the latest LTS. But Jessie is kind of getting a little bit long in the tooth. So it looks like I must be running on it just a completely old version of Debian is probably what's going on here. But let's take a look at a few of the other ones. When you look through the package names, it's not just Linux or it's not just glibc. ImageMagick. My app doesn't use ImageMagick. Why am I getting a vulnerability in ImageMagick for something I don't even use? And the more you go through here, the more you start to find this. So I'm going to go through, I'll find OpenSSH, well, I probably need that. SQLite, I'm definitely not using SQLite. libvpx, don't know what that does. Might be important. And so what starts to become very clear is that I've got a collection of problems that are starting to pile up here that are leading to this huge surface area of attack. So if we go back to the deck, how do we actually go and fix all these problems? I mean, 623 vulnerabilities, you can't just take them one by one. It turns out that most of these fixes fall into a set of 3 common buckets. The first bucket is, install patches. Easier said than done, but this is something that you need to do often. You have to do it daily in your Docker build files. Add the good old apt-get update and apt-get upgrade commands, or for whatever distribution you use and love most. Update them, apply patches. One of the great things about the Kubernetes world is that it used to be with virtual machines, planning patch times was actually kind of hard. We may have to take the product out of production. Doing them batch over time and handling all the restarts was difficult. With a containerized infrastructure, there are all kinds of tools built into Kubernetes to help us handle this and to make it easier. So that's kind of the first bucket. The second bucket is removing the packages you're not actually using. A stock Debian or Ubuntu operating system comes with a mountain of stuff that makes it great for portability. Most applications, most of the time, can run on an out-of-the-box installation of Debian or Ubuntu. But the cost of that is that it's got a ton of packages you probably don't need for your application. And you really have to go in and ask the question, how many of those did you really need, and can you remove them? And lastly, in kind of the most extreme case, which we're going to take a look at next, is moving to a different distribution. Kind of now that we've started to understand the ramifications of using these giant operating systems, we've started to look at things like Alpine, Debian Slim, smaller distros, less attack surface area. So let's give it a try, and let's actually go deploy, see what it's like to deploy a more secure container image. All right. So I'm over here in my CloudCats application. I'm going to go into the web tier, and you can see here I've got a Docker file. Nothing too fancy. As I mentioned, Node 4. So let's go ahead and let's upgrade this. Oh, running VI on stage. What could possibly go wrong? All right. So instead of Node 4, I happen to know that 10 is the latest version that's available, so let's do that. And instead of Debian, the full Debian package, I'm also going to tell it I happen to know that there's an Alpine package out there. Alpine is a much smaller distribution, supports a very tiny subset of packages, but often just works. Oops. See, I got what I deserved. I got fancy. All right, so just as an example, I'm going to do a Docker build, example, build the directory just to make sure that everything works. All right, and it looks like it builds. And then I'm going to run, I have an update script that does the build, pushes it to container registry, and actually replaces the image in my production service. Out of sheer laziness and a lack of desire to type out the full Docker push command, I'm just going to run that bash script. And we're building again. We have CloudCats. Most of the layers in GCR already exist. And we're going off, and we've just rolled the whole thing out. So now the new version is rolled out and available on cats.jbeckwith.com. Let's go take a look at what's going on behind the scenes now. So we can see we have an image we just uploaded now. First thing to take into account is, hey, it's done scanning. That was pretty fast. We went from an image that was 300 megabytes down to an image that's 75 megabytes with the move from Debian over to Alpine. And most importantly, I'm not going to claim there are no vulnerabilities, because that would be foolhardy. There were none found against the known list of vulnerabilities in that version of Alpine, that version of Node, fully patched. So we went from something that had 623 vulnerabilities by paying just a little bit more attention to what we used as the base of our Docker image and making sure it was something we understood and where it came from. We've made it that much, we've reduced the attack surface that much. All right, let's go back to the deck. So it's all well and good that we fixed it, but this isn't really a good process. Relying on me to go mill around inside of the container registry UI, discover that there are vulnerabilities, react to it, and then just kind of hope it doesn't happen again, this is not a strategy for success. So the next thing that we're going to talk about is getting a good CI/CD process that uses these tools and takes them into account. Every time that we're shipping code or we're developing an application, we go through this natural evolution, and you'll see slides like this. You've probably seen them all through the week with the cloud build announcement and the other things that we've been working on. We go from code, we build, we test, and then go into production. And at each step along the way, we want to be able to make the right kinds of checks to make sure that we're not making mistakes. This is where the container analysis API that we have, which is part of our container scanning infrastructure, really becomes helpful. When you do the build, we can check what vulnerabilities are available in this package. We can write what's called an attestation, or a sort of statement of support, saying that during the build, we checked. I'm giving it a stamp of approval. This has been scanned. When we run the tests, same thing. And then lastly, at deploy time, we want to ask that question. It's great that you're trying to deploy a container. Who built it? Can you verify that it was my build system? Can the build system verify there were no known vulnerabilities? Can it verify that all the tests passed? Can you verify any other sorts of things that are critical for my business? Does it have the right licenses? What promises can I make, and what infrastructure is in place to help me make all of those checks before I let this thing into my production Kubernetes cluster? So that's all well and good. We can now test, going on. We have a better process. What do we do when a new vulnerability is discovered? So we have a couple of things to help make this easier. First, we use what's called the activity stream inside of the Cloud Developer Console. You'll get a notification, and this is actually, if you're enrolled inside of the alpha, then you'll get this today. And every time a new vulnerability is discovered, you can actually click on that little bell. It'll show an alert with a number, and you can go in, dig deep, get information, use the UI that we talked about. The other thing you can configure are email notifications. So I get a daily roll-up that has all of the security vulnerabilities that are found. I say all of. Traditionally, I go fix them now. And lets me know if there's something that I need to work on, if you use email as your workflow tool. The one that we don't talk a lot about, which I don't think many people actually know we have, is we have a mobile application. There's an Android app that works fantastic, and you can actually configure that to get push notifications. So if someone in your team pushes something that has a vulnerability, if it got past all these other controls, you can actually get a push notification letting you know you have a vulnerable image sitting out there in production. And then lastly, like everything that we release from Google Cloud, there is a fully featured API. Now, the fully featured API lets you do your typical CRUD operations. You can create new occurrences, create notes, read all the information. You can do that on a loop. But the one that we're going to look at next is our PubSub API. Now, what's cool about this is with PubSub, we'll publish a new event every time a new vulnerability is found, and then you can use that to integrate it into any workflow, any tool that you want to use. Let's take a look at how I actually did this over on the desktop. All right. So I'm going to go over to Cloud Functions. So Cloud Functions is an easy-to-use functions as a service product, and essentially the idea is that you can have very simple hooks to execute small, discrete pieces of code. They've had a couple of really cool launches this week that you should probably go check out. One of the features of it that I like the most is that you can directly trigger an event based off of something coming into PubSub. And when you come over here, you'll see all of the potential trigger type. Instead of an HTTP endpoint, I'm going to look for a Cloud PubSub endpoint. And then it'll just list all of the topics that have already been created. Since we're in alpha right now, it's called Resource Notes Occurrences V1 Alpha 1. So yeah, I expect that you'll all remember that and be able to go type it after this. But it gives you the drop-down list. And what's cool is now that I have those events, now every time that we get a new vulnerability discovered, I can go into here, write some JavaScript, and react to it. I'm not going to make you suffer me writing JavaScript on stage. There are other talks you can watch me do that, and people suffer through it. But I've already created a trigger that actually goes and does this. Let's take a peek. So what I decided that I wanted to see happen is I have this code it happens to be in a public GitHub repository. Don't post your security vulnerabilities to a public GitHub repository. This is just for demo purposes only. But what I'm doing is I'm going to use the OctoKit, the GitHub API. Every time there's exports.newvuln, every time there's a new vulnerability, I'm going to authenticate to GitHub. I'm going to grab the message that comes out, and I'm going to go create a new GitHub message. So it'll just say, new vulnerability found. Let's see if it worked. All right, so here's the GitHub repository. If you too want to be able to put dogs against cats, here it all is. And we look at issues. I have 204 issues, probably stemming from some of the previous images I had pushed. You click in, and it'll give you kind of some of the API information. From here, you could use this to use the read API to go get all of the information you want. So if you wanted to integrate with your existing bug system, if you wanted to integrate with your existing alerting system, if you had special things that you had set up that you wanted to use with Stackdriver, you can use this API in PubSub and Cloud Functions to easily kind of glue it all together. So let's go back to the deck. Except I'm taking this time. All right. So I think that was the reacting to new vulnerabilities demo. So lastly, you can find the vulnerability information inside the developer console. We talked about using the mobile application and push notifications. We talked about customizable API-based workflows with PubSub, and about Cloud Functions just in general being really good glue for these sorts of things, especially when PubSub is involved. Now, you may be thinking, this is great if you're a GCP customer, but what if you're just running, if you have Kubernetes and you're running it on-premise? Or what if you have Kubernetes and you're running this on another cloud provider? Well, what about open source? That's great. One of the projects that we have worked hand in hand with just a whole bunch of other companies on defining is called Grafeus. And Grafeus, I'm going to say the sentence, an open artifact metadata API to audit and govern your software supply chain. What the hell does that mean? What that actually means is that we have a consistent way for vendors to tell us what artifacts do we have in our build system and running in production, what vulnerabilities are out there, and what auditability do we need to have. And so you probably don't just have Google Cloud scanning your containers. You might have Aqua Security, you might have Black Duck, you might have Twistlock, you might have any number of vendors that are going and verifying different pieces of information about your artifacts. This is an open API designed to be able to store that information. And there's a reference implementation available on GitHub. So the metadata types and providers, they grow and they change. As we pick up new companies and we work with them and they ask to store different types of information, the standard has been moving quickly. We've had open contributions from JFrog, Red Hat, IBM, Black Duck, a lot of the companies that we just talked about. This wasn't done just at Google. This is something that we did with the community. You can get a nice bit of visibility, both in terms of assets that are in your source code control all the way through the build system to production. And it can be used both in the cloud. The container analysis API we provide on Google Cloud implements the Grafeus open API. So taking that and connecting it, so it's great. We have this open API sort of database artifact analysis thingy. How do we connect that to Kubernetes? It would turn out that Kubernetes has this really cool feature called the admission controller. And it essentially sits in front of any command that's going to be run, intercepts requests and says, lets you write a little hook of code that basically does the, yes, this looks good, or no, get out of here. Where this is really great is for, remember how we were talking about checking to make sure that there are no vulnerabilities and that who built the container? The Kubernetes admission controller is how we can actually go do that. If you're looking for a tutorial on how to work with Grafeus and how to use that with, and how to set up your own instance of it, there's a great tutorial out there on GitHub made by Kelsey Hightower, who spoke here this morning. I highly suggest to go walk through that and check it out. The next thing that we're going to talk about, we were able to store the data. We have this admission controller, but you'd have to do a lot of glue to kind of put the pieces together. We are also producing Cretus, another open source project built alongside Grafeus that makes it easy to take and check assertions before running your containers inside the cluster. So you can test assertions, plug directly into the existing admissions controller, check build provenance, ensure build scanning happened, and there are just a lot of neat little things that you can do with it that it's very easy to extend. Again, open source, again, available on GitHub. So let's say that we wanted to take our cluster and we wanted to lock it down and say, okay, Justin, he deployed this thing with Node.js 4. It was terrible. It had 623 vulnerabilities, I think was the number. I don't want to let anybody deploy anything into my cluster if it has vulnerabilities. And so we can create a configuration like this with Cretus that essentially says this is an image security policy. There are some images I'm going to tell you are just okay. But other than that, I want to make sure that you do not check in any containers that have a high security vulnerability in it. Just will not allow it. But except for CVEs 1, 2, and 3, our security team looked at and they said those ones were fine. So I have this tight control over what I'm allowed to push into my registry. And so let's actually take a look at how this works and how you can try it today. Every time back to the cat. All right. So I have another Google Cloud project over here, and we're looking at some of the images I have in container registry. We're going to dig down, and I have this rather benign-looking Java image that has one critical vulnerability inside of it and 31 others. Again, the goal here was to have a cluster where I don't let anything like this with a high critical vulnerability pass. So I'm going to activate the Cloud Shell. If this is slow, I will blame it on the Wi-Fi. Awkward dance. All right. So we're going to go into here. I'm going to take a deep look at the image, and I need to copy this. I'm going to get the full SHA. And if we look in this directory, you're going to see that I have a pod.yaml. And this pod.yaml, all it does is says, this is the name of the pod we're going to run. Please use this image, which matches the one that we had pushed, and open up port 80. So let's go ahead and let's try to start our pod on the cluster. So I'm going to do a kubectl-f, kubectl create-f pod.yaml. And pretty quickly, it's going to try setting that up. It's going to take a look at the image. It's going to take an uncomfortable amount of time, and then it's going to reject my request to create the pod. And you can see here the error that we're getting. The admission hook, Critis validation hook, denied the request because it found violations based on our policy. So now we don't have to worry about who's deploying what into our cluster. We can give tight controls on our cluster, both inside of Google Cloud and in our own Kubernetes /Grafeus/Critis deployment, and lock it down and ensure that we have a more secure environment. Let's go back to the deck. So what is the timeline on all of this? I mentioned that we're currently in alpha. All the features we saw today are available, and you can use them inside of the alpha group. It integrates with your existing images that are pushed into GCR. So if you're an existing Kubernetes or existing container registry customer, we can actually turn this on, and it all just lights up today. To get access, you can join the Container Analysis Users Group, where we're going to share the link for that in a moment. The things we're working on, what's coming up in the works, we had a lot of this we wanted to get ready for this week. It's not far away. It's coming very soon. The big one for me is support for Red Hat Linux and CentOS. Cloud Security Command Center integration. So kind of bringing this into the security control stuff that's available at the organization level and plugging in all the policy and notification management there. And then just general UI optimizations and bug fixes. So to wrap this all up, security's hard. Any of us that have worked in the field for a while know there's one thing that will fix it. There's no silver bullet, but our businesses depend on it. We have tools that are going to help you get through this. We have the right CI/CD offerings. We have the scanner. We're doing all of this in the open, and we want to do it with you. And lastly, if you want to join the group, please send your questions to containeranalysis@google.com. One last thing. We actually released a new site today, cloud.google.com/containers/security, that goes way more in depth on everything I talked about today, as long as a variety of other topics extending, all the way out into the VM image, to network security, to IAM, to all those other pieces that we need to think about. Really recommend folks to go give this a look and send us feedback, because we're really excited about it. And thanks.